All right, welcome back, everybody. We are now on lesson 4.5. This is operations with polynomials, focusing on subtraction as well. And my name is Miss Mitchell, and we're going to be recalling adding polynomials, and then we're going to go into subtracting polynomials. Let me make this just a little bit smaller. All right, so if you can recall, we're going to simplify each expression by combining like terms, and if necessary, first use the distributive property. And then what's most important is that we write our answer in descending order. So we want the highest exponent to the lowest. We want our variables ordered alphabetically, and then constants are always last. All right, so keep that in mind while we're working these problems. So we've got negative 4s cubed plus 2s minus 3 plus negative 2s squared plus s plus 7. All right, so first things first, we can just bring this left side down, right? Nothing's going to change on that. So we'll have negative 4s cubed plus 2s minus 3. And then this positive isn't going to change anything over here. So even though we would distribute this positive out, necessarily, we don't have to do that because positives don't change anything. So let's write that down. Positives don't change anything. So that means that we can just bring this down the same way. So we would have, because if we did distribute this, we'd have positive times a negative, which would just stay the same, right? So we can just bring the second side down the same way. All right, so now we need to combine our like terms. So we have 4s cubed. All right, do we have any other cubes? No. All right, so then we have 2s. Well, do we have any other plain s's? Well, we have one over here, so we can underline this twice. All right, and then we have negative 3. And that can be combined with 7. And then we're left with negative 2s squared. So if we write this with the highest exponent to the lowest, alphabetical variables and constants at the end, when we combine this, we'd have negative 4s cubed, because that cubed exponent goes first. Then we'll bring down this negative 2s squared. All right, and then we've got 2s and s. That's going to give us 3s. And then we'll do our constant, which we have negative 3 and positive 7 is going to give us positive 4. All right, same thing on this side. We are not going to have any changes going on up here, so we're just going to bring this down and then combine like terms. All right, so now we've got it copied down. Let's look at our like terms. So we have 8p cubed. Well, we don't have any other cubed exponents. Right, then we have negative 6p, and then we've got 9p squared. And we've also got 2p squared. But notice because of these squares, we can't combine these, right? But we do also have negative 5p, which can be combined. Right, and then we've got these exponents, these p's with a square on there, so those can be combined together. And then 11 is on its own. All right, so we've got 8p cubed. Our next exponent would be squared, so we have 2p squared and 9p squared. It's going to give us 11p squared. All right, and then we've got negative 6p and negative 5p. It's going to give us negative 11p. And then our lone constant, so minus 11. All right, same thing going on down here. We're just going to bring this whole thing down. But now we've got a 3 in front of this. So this 3 needs to be distributed. So we have 3 times 2b. So that's going to be 6b. 3 times negative 5c is going to be negative 15c. And 3 times negative 2 is going to be minus 6. All right, so in that particular problem, we had to distribute this 3 out, right? We didn't just have a plus sign. We also had a number that we had to distribute. So now we can go ahead and underline our like terms. So we have 3a squared. Well, we don't have any other a squares. Now we just have b. Well, we also have 6b. And then we have 5, which can be combined with negative 6. Give it one more line. And then we're just left with negative 15c. All right, so now let's combine our like terms. So we have 3a squared, that's our highest exponent, so that's going to go first, so 3a squared. All right, we've got b, which can be combined with 6b, so that's going to be plus 7b. All right, and then we've got 15c, and this is going to come next because we're putting it alphabetically, so minus 15c. And then we've got positive 5 and negative 6 is going to leave us with negative 1. All right, on D, notice we have a negative sign. Well, this negative does not work the same way that a positive does. This negative does change things, so we need to distribute this negative over. So we'll now have negative 6x, positive 10y cubed, and negative 3z squared. And then we also have this 5 that we need to distribute over. So we'll now have 25y cubed, 15x minus 20. All right, and now we can go ahead and combine those like terms. So we have negative 6x, which can be combined with 15x. We have 10y cubed, which can be combined with 25y cubed. Then we have 3z squared, that's all on its own, and we have 20 that's all on its own. All right, so we're going to put that in alphabetical order and highest to lowest. So first things first, we're going to use these this 10y cubed and 25y cubed. So we've got 35y cubed. All right, and next we've got z squared, so minus 3z squared. All right, now we're going to use negative 6x and 15x, and that's going to give us positive 9x, and then our 20 just going to go right there at the end. So just a whole lot of combining like terms. All right, now we need to talk about subtracting polynomials. So multiplication property of negative 1. So negative 1 times a is negative a. We know that this negative a has an understood value of 1. We shouldn't have to write it out each time. But anything times 1 or negative 1 would determine the sign, but the numbers would stay the same, the value, right? So that's why a stays the same, but the sign changes. All right, so now we need to simplify each expression using the distributive property and combine like terms. So not much different so far. On this one, notice we don't have anything being distributed out over here, and over here we've got a negative sign, so that does need to be distributed to the right side of this equation. So let's bring this down. We've got 10x squared plus 5xy minus 3x squared y squared. Now we need to distribute this negative sign across. So we will now have negative 6xy, negative x, positive 2x squared, and positive 10x squared. Right? And then all we've got to do is combine like terms. Same principle, but now we just need to make sure we're really paying attention to those signs, okay? So we have 10x squared, which can go with negative 3x squared, and also 2x squared and 10x squared. So lots going on there. Then we've got 5xy. Oh, I'm sorry, this is one value. I didn't notice that. So we've got 10x squared, 2x squared, and 10x squared. Then we've got 5xy, which can be combined with negative 6xy. Then we've got negative 3x squared y squared, which is a value on its own, and negative x, which is a value on its own. So now that we've got this underlined and ready to go, let's go ahead and combine like terms. So we're going to start with this xy variable, So we start with the xy, and then out of these two, the ones that have a squared is going to go first. So we're going to have negative 3x squared y squared. So that one's gone. And now we've got 10x squared, 2x squared, and 10x squared. So watch your signs here. So we've got 10x, 2x, and 10x. That's going to give us 22x squared. And then we've got 5xy and negative 6xy, which would leave us with a 1, which we should know that we don't have to write. So we're just going to put negative xy. So those are gone, which just leaves us with our lone x, and we're just going to bring that down. Same thing on the bottom. Nothing's changing in this one, so we can bring that down just the way it is. But we do need to distribute this negative across over here. So we'll have now negative 3x and negative 5. And then let's distribute this positive, which wouldn't change anything, so we know that we can just bring that down the way it was. All right, and now, once again, let's just combine some like terms. So we have 2x squared and 7x squared. We have negative x and 3x. Oh, and 3x right here. Missing that one too. We have positive 3, negative 5, and negative 9. All right, so let's start with our squared exponent. We have 2x squared, 7x squared. That is going to give us, wait, what am I missing? Yeah, 7x squared, 2x squared is going to give us 9x squared. All right, and then we're going to move on to the x value. So we have negative x, negative 3, and positive 3. So these 3's are going to cancel each other out, and we're left with negative x, so minus x. And now we've got positive 3, negative 5, and negative 9, which is going to give us, so 3 plus 5 is going to give us negative 2. Negative 2 minus 9 is negative 11. So 9x squared minus x minus 11. This is a lot to look at, and I'm aware of that. So if you get overwhelmed and you skip a step or you bring down an exponent that could really have been combined with something else, you can just combine it from what you have, right? So if this weren't finished, say we'd left out, an x squared that we didn't realize we should have combined, just take one more step and combine it and get your final answer, okay? All right. So now, applications using operations with polynomials. Use what you know about adding, subtracting, and multiplying polynomials to answer the following question. So the perimeter is given. Find the length of the missing side. So this is where the subtraction comes into play. Let me plug my computer in really quickly. All right. So one thing we need to make sure we know is, what is a perimeter? Well, perimeter is add all sides, right? So they added up all 3 sides to get this answer. So we need to figure out what is missing for this last side, right? So how are we going to do that? What do you guys think we would do to solve for this? So if we were given p, then we need to subtract 3x minus 2 and 6x plus 6. So we'll call this a and we'll call this b. So we now have p minus a minus b. Right? And the perimeter it gave us was 13x plus 11. So we would have 13x plus 11 minus 3x minus 2 minus 6x plus 6. All right, and it's important that you put these negative signs outside, the subtraction signs outside of the parentheses, because they're going to change the value of these numbers inside of it, right? So if you didn't distribute those, you would get the wrong answer. So we'll bring 13x down plus 11 like normal, and then distribute these negative signs out. So we now have negative 3x plus 2 and negative 6x minus 6. Now we can combine like terms. So we have 13x, negative 3x, and negative 6x. And we have 11, positive 2, and negative 6. Right, and when we combine those, we've got 13x minus 3x, that's going to give us 10x. 10x minus 6x is going to leave us with 4x. Then we've got 11 plus 2, that's going to be 13. 13 minus 6 is going to give us 7. So 4x plus 7 is our final answer. So the missing side is 4x plus 7. All right, now B tells us to write an expression representing the perimeter of the figure. So now we are given all three sides, and we need to figure out what our perimeter is. So in this case, perimeter, once again, we're adding. So we know that our perimeter is going to add all three of these sides. So we're going to write this in some parentheses. So we have 3x plus 8, and the reason we write it in parentheses is just in case, like in that previous question, it changes the value. So 3x plus 8, 4x minus 1, plus 5x plus 2. Well, we know that these plus signs aren't going to change the value, so we can carry that down just the same way. Right, and now all we got to do is combine our like terms. So we have 3x, 4x, and 5x. Then we've got 8, negative 1, and positive 2. So we have 3x plus 4x. That's going to give us 7x, plus 5x is going to give us 12x. Then we've got 8 minus 1 is 7, and then 7 plus 2 is going to give us 9. So 12x plus 9. All right, last question before I send you on your way to do your practice. C says to write an expression representing the area of a shaded region. So we're really given two rectangles here. And it says to find the area of the large rectangle. So area, hopefully we all remember this, is length times width. So we've got x plus 6 times x plus 3. And we need to go ahead and multiply that first, right? So hopefully we remember how to multiply. We're going to distribute this x to both, and then we're going to distribute this 6 to both. So we would have x and x. Remember, we add our exponents, so we have x squared. X and 3 is 3x. Then we've got 6 and x is 6x, and 6 and 3 is 18. Right, and then we can go ahead and combine those like terms. So we have 3x and 6x. So we'll have x squared plus 9x plus 18. Right, so this is the area of our larger rectangle. And then it says to find the area of the small rectangle, which was x minus 2 times x minus 4. And we're going to distribute just that same way. So x to both and negative 2 to both. All right, so we have x and x is going to be x squared. X and negative 4 is negative 4x. Then we've got negative 2 and x is negative 2x. And negative 2 and negative 4 is positive 8. So then we can, once again, combine these like terms. So we have x squared minus 6x plus 8. All right, but now it wants us to represent the shaded region, which is just this part, right? That's really bad drawing, but just this orange shaded part. And the only way to do that is to get rid of what's in the middle. So we need to subtract this small rectangle from the large. So we would have, and let's put these in parentheses because we're going to be subtracting, right? Large area minus the small area. So that negative sign is going to be distributed and change the values. So we have x squared minus 9x plus 18 minus parentheses x squared minus 6x plus 8. All right, so first things first, we need to distribute this negative sign out. We know that this part is not going to change. So we have x squared minus 9x plus 18 minus x squared plus 6x minus 8. And now all we've got to do is combine those like terms. So we have x squared and x squared, and now we've got negative 9x and 6x, and then we have 18 and negative 8. So we're just going to combine those like terms. So x squared and negative x squared are going to cancel out and go away. But then we've got negative 9x and positive 6x. I just realized I copied that down wrong. I knew that was wrong. Positive 9, positive, positive. That is my mistake. So we have 9x and positive 6x, which is going to give us 15x. So those are gone. And we're left with 18 and negative 8, which is going to be plus 10. So 15x plus 10. All right, so that is all for lesson 4.5. Please feel free to print the notes along and follow along with this video, and then do your best and complete the practice. If you guys have any questions, please let your teachers know. Have a good day.